Hello and welcome everyone, and thank you for joining today in our webinar. The webinar is about advanced hunting with the cloud security graph in the Microsoft Defender for Cloud. And my name is Giulio Astori. I'm a principal product manager for Defender for Cloud, and I am very excited to walk you or guide you through leveraging the powerful capabilities with the Defender for Cloud using the XDR Advanced Hunting and the Cloud Security Graph data. This allows you to enhance proactive and reactive security, and obviously the risk analysis, detections, and investigations effort. I'm going to move the next slide right now. So here is a very quick view of the agenda. Basically, what we are going to cover in the next 45 minutes. We're going to have a very quick overview of Defender for Cloud, the Cloud Security Graph, and then the XDR Advanced Hunting. We then are going to look into we're going to have an overview of the exposure management tables. We're going to look into how to use K2L, which stands for Kusto Query Language, for writing a specific query to be used in advanced hunting. And obviously, we're going to build some custom queries or show actually some custom queries. So without any further ado, let me go ahead and go on with the first slide. So today, in today's world, basically, our digital environments has the picture of try to replicate the whole gist of it. Those digital environments are very much more complex than ever been before. We have resources everywhere. Obviously, in the on-premises, as a legacy infrastructure were originally built, and then in the cloud. When we talk about cloud, we're talking about multi-clouds nowadays. Three of the most biggest clouds are the Azure, AWS, and GCP. Customer now adopting only one cloud nowadays. They're adopting more than one, at least two. Then we have a complex identities. We have many endpoints, API endpoints. Customers start using a lot of SaaS apps, and so on and so forth. This creates a messy and constantly changing attack surface. Historically, organizations have deployed numerous security tools to protect those different areas, especially when it came down to their on-premises. While those tools are valuable, they often operate in silos, each with its own dashboard, alert, and data format. Customers are often struggling with a plethora of dashboards, schemas, APIs, where each tool pretty much cries for attention. This is a very big fragmentation, and it makes the whole thing incredibly difficult to get a unified view of your security postures. It makes difficult to understand how risks in one area might impact another area. And truly, it makes it difficult to prioritize what matters the most for the business. We end up being largely reactive, constantly responding to the individual alerts, rather than pretty much being proactively and addressing the underlying exposures. Those challenges highlights the need for a fundamental different way to model and analyze our security landscape. We need to start thinking a little bit more different, more like our adversaries, like those hackers, if we actually want to stay ahead of them and their threats. Remember that defenders, we are the defenders thinking a list. Attackers, on the other hand, they start thinking in a graph. As long as this is true, the attack will always win. So the traditional security tools often present information in list of vulnerabilities, list of assets, list of alerts. But the attackers exploit the connections, the relationship between them, so they can move through their environment. So this is when Defender for Cloud comes in. Defender for Cloud, it is very much a modern approach designed to tackle such complexity head-on. It's a full synapse security solution. And the core idea with Defender for Cloud is to move from a reactive stance, basically waiting for an incident to happen, to a proactive one, meaning actively seeking out and neutralizing potential threats before they can actually be exploited. A core component of Defender for Cloud, it's a capability to contextualize all the security findings, basically generating attack path and a security risk analysis. Defender for Cloud continuously discovers assets across your cloud data estate. If it's Azure, AWS, or GCP, it will automatically identify and assess risk to sensitive data with integrated data-aware security posture management. Also, Defender for Cloud has agentless and agent-based scanning solutions, which will provide a full visibility across your environment and being able to identify and prioritize those potential lateral movement paths. Defender for Cloud also integrates critical data signal from Defender External Attack Surface Management, ESAM, to monitor internet exposure to resources. Also leverage Microsoft Purview information types, labels, and data context to allow you to identify the resource with the sensitive data. All this allows you to cut through the noises and get in front of your most critical risk across your multi-cloud and hybrid environment. Central to those capabilities, there is one thing that stands, and that is the Cloud Security Graph. The Cloud Security Graph, it is the core of contextualizing the security insights. Basically, the Cloud Security Graph connects the dots across all those security insights, will consolidate the posture's findings from the code itself and from the cloud workload in a runtime across your servers, across your containers, across your database, storage, and more. Defender CSPM also, or Defender for Cloud in general, basically also natively integrates with the whole security.microsoft.com Defender portal, and Defender CSPM integrates with the Microsoft Security Exposure Management. Such integration allows you to have an enrichment when it comes down to your enterprise security posture visibility with your cloud and application security insights. MSAM, which is basically Microsoft Security Exposure Management, will consolidate security postures data from multiple Microsoft services, including Microsoft Defender for Cloud, Defender for Endpoint, Defender for Identity, and others. We'll consolidate all this into a single pane of glass. The integration enables the security team to view and correlate vulnerabilities, misconfiguration, and exposure across the clouds. Will allow to correlate endpoints, also identities, and application layers. Will allow you to prioritize the remediations, which are now based on the risk context and the attack path analysis. A fundamental aspect of the exposure management, if we want to get a little bit more deep into it, is its underlying data modeling. It's basically the exposure graph, which is a specialized graph-based model that consolidates, and then this word is repetitive, consolidate, it's used a lot, right? Which basically consolidate a wide range of security relevant information by the entities within an environment and the relationship between them, between them. This aligns basically with the principle that we just mentioned earlier at the beginning, the principle that's saying defenders as things in list, where attackers on the other end things in a graph, right? And as long as this is true, again, the attackers will win. So with exposure management, with exposure graph, you are able to visualize those connections, functional like a dynamic map of your security landscape. Here there is a oops, sorry. Here there is a picture that shows. First of all, sorry, I had it in the wrong order. God, apologize. The clicking is not working on my side. Okay, here there is a pictures of the exposure management overview that you can access via security.microsoft.com portal. It's many of us refer to Microsoft Defender portal, or some refers to the Microsoft XDR. Now, the next picture on the other end is a picture of those two, the table that forms the graph, pretty much, right? Those are the two tables. They're available right from the Advanced Hunting in the same portal, and they are called Exposure Graph Edge and Exposure Graph Nodes. For this webinar, the scope is actually to learn how to leverage some of those core components by leveraging the data within those two tables, okay, which is basically the closest data sets that you can access. Now, I'm going to jump right on. I'm going to actually, before the demo. So when it comes to the actual tables, I have another picture here that shows basically the schema. Obviously, you can get these pictures either by opening up the table or either running like a schema command from the KQL, but this basically comes right from the documentations. So here you have the exposure graph node and exposure graph edge. Now, the exposure graph nodes table serves as the cornerstone for your custom analysis. It represents various entities within your environment. Each row of this table describes a single node, including its unique identifiers, basically a broader classification of the node, the categories, and the properties. Okay, the node itself is very flexible, and such flexible nature of its own properties allows for a really wide range of entities types. You can find user, you can find the VMs, you can find deployment, you can find AI, artificial intelligence module, vulnerability, so on and so forth. All those will coexist in the same table. An example is, for example, you take the node label, okay? The node label can be a Microsoft.compute/virtual machine. The node property might detail the OS versions, the patch status, or even the network configuration. Let's say the node label it's a users, then the node property for that node might describe the MFA status, maybe describe the identity provider or the group membership. And so here you have the whole list of the columns for the graph nodes and a whole list of a graph edge. On the graph edge, on the other end, you have all the data that defines how those nodes interrelate between each other. So the edges, it's basically the data types that will identify how to connect those nodes. Each entry inside of the exposure graph edge will correspond to a directed relationship between the nodes. There is an arrow from one entity, which is the source, to another entity, which is the target. Like in the node table, it also has a JSON-based property, which is called edge property. And in the edge property, the relationships, specific relationships or details are exposed to that. Okay. Now, I'm going to add a couple more things to this description, and I'm going to go into the demo. One of the things that I want to also highlight about those two tables is the actual concept of variability. Okay, the concept of variability in a data model in general refers to a degree of flexibility or dynamics, or how much dynamic there can be in how the data structure are actually defined and used. Okay, one of the greatest strength or one of the greatest value of those tables is exactly that, this flexibility. Rather than forcing every node or edge into a rigid schema, the database accommodates new or a variety of attributes thanks to two columns. One is the node property, and the other one is the edge property, which at the end of the day are JSON field. Why the variability matters? It matters because the security context then is a very fluid. What I mean when I say fluid, a user as a node may track new authentication attributes or vulnerabilities in the node might store emergent threats, like, that it is part of intelligent data. By relying on those JSON-based columns, the actual graph can adapt very quickly to changing information without requiring any schema alterations in this moment. Okay. Now, another thing that I want to share here is some best practices. Okay, you can use a KQL statement like parse JSON back underscore keys or extract underscore all in order to find information between and learn about the node properties and edge properties. And I will show in my demo. One final thing, sorry, I forget to switch on the slide. One final thing is the actual relationship between the node, between the two tables. Okay, so both nodes and edge tables form a direct graph. That's important, where the node ID will serve as the linkage. So the linking field for the source node ID and the target node ID. Okay, you will see that frequently we'll use the join statement in order to connect those tables to gain the full context. Okay, typically the source node is the actor or the origin. Okay, where the target node is typically the entity which is acted upon. Let's say like a VM, a storage account, or database. And you can chain together multiple edges, which are basically important to reveal multiple hop sorts of path. Okay, which is very crucial and important when you do some sort of like advanced hunting or risk analysis. Now, let me take my demo environment up, move the screen right here. And I believe this is 120, so you should be able to see it. So first of all, those tables are in the advanced hunting section, which is right inside of the investigations and response. Okay, under here, there is a section called for exposure management. And then here, those are the two tables, exposure graph edge and exposure graph nodes. You can expand that and see the content, basically what kind of columns and property it has. You can click over here and view a reference, which gives you some information about the actual table. You can see pretty much what kind of properties columns has it. And then you can jump right into learn about the tables, which is the very first thing you're going to do. Typically, you want to learn the tables. because you want to start understanding the data that could be modeled through the K12. Okay, so earlier I mentioned one of the best practices at the very first stage when you start using any table, but specifically those ones, it's to use things such as parse JSON or bag_key or extract them all, right? Why? Number one, because the data inside of these tables are very much like JSON structured, okay? So parse JSON is very useful to kind of like extract the information in a nice manner so you can see what's in there. So let's use some of those concepts here. Here I use parse JSON, and then I'm going to basically query the node table, the exposure graph node table. So if I run this query, what am I finding over here? Maybe I should reduce from the last 30 days to a little bit less next time. So what I'm going to try to do over here, I'm trying to understand a little bit more about, okay, let's look for those records that are identifying a Microsoft.compute virtual machines or any VM. And I want to expand the node properties, which holds most of the volume informations. So I'm going to use parse JSONs. And then once I do that, I can use the raw data. I'm sorry, I can use the parse JSON to create an extended variable, which is called raw data. All right, and then at that point, I can examine some of the informations in there. Okay, so in here, particularly, I'm looking for any virtual machine that is exposed to the internet. All right, so basically, I'm getting a results of 7 VMs within my environment that are actually exposed to the internet. So if you really look at what we've done over here, we pretty much replicated something that is available through Defender for Cloud, the Cloud Security Explorer. Okay, there is a query template that says Internet Exposure VM. So you can open that query, you can run it, and look at this. You got 7 records. Basically, what is the difference here? The difference is that with the Cloud Security Explorer in Defender for Cloud portal, you have to build the query through here by obviously selecting the proper filters and conditions, or you can basically, like I did it, I can use some of the template available right here, which are now the more predefined queries. But you cannot really do much other than you cannot save the query. You can share the query in the form of a link, but you cannot save the query. So let's say that I build the query here, like this one. Let's suppose this I don't have a template, and I just build this query. I want to save it. I want to save for next time because I don't want to, constantly replicate the effort to build the query up. Right now, obviously here there are two things that you added. Right, you select virtual machine, expose the internet, and you're done. But imagine if you want to build something a little bit more complicated, something more complicated, something like this, let's say, right? And then you can have additional ones that are a little bit more deep into the level of condition. Then, it's very hard every time to do this and that. And then there is not any options to actually build your own template and save over here. So at that point, you have an options over here. You build the query using pretty much the data that is also consumed by the Cloud Security Explorer in a nutshell. And once you do that, you have options to save it. You save it as a function if you want to, and then use in another query. You'll save it as the actual query. And when you save an exit query, you can have your own folder structure. And let's say I want to save in my exposure management. Give it a name, Internet Exposed VMs. oops, VMs. And here I have it now. So next time that I want to leverage this query, I can go in the query under my query, and I have here internet exposed VM. So I can share this with others if I want to, but also I can build my own library, like I have multiple ones. Now going back still in those best practices and then starting like understand how is it, okay? So let's say that I want to now find, expose an internet, but with high vulnerabilities. Similar, there is also one of those things like here too. It's called internet exposed VM with high vulnerabilities. Okay, I can do that as well very quickly. I can build the query. Obviously, you learn the query. And if I run it, the query, I should be able to see that I have 11 items here. Okay, so 11 records. There are not only exposed on the internet, but I have also high vulnerabilities. In this case, either high or critical vulnerabilities. I'm looking for either high or critical vulnerabilities. Now, if you really don't know exactly what type of a condition, well, one way to do it is, number one, let's start from here. You want to look for Microsoft Compute Virtual Machine. If you run just that one, let me reduce a little bit to 24 hours here. And then run it, the query. So you can see I have a 62 items. So one way to do is obviously start like dissecting the actual record. One of the column that is very important is, as I said earlier, the node property. This is a huge dynamic JSON style-ish type of data. So you can click it and you can see inside of that there is a raw data. So you know that when you want to progress and build your query, you start with the node. If you go on the graph node, there's something with the node label and says, okay, I want to start with the Microsoft Virtual Machine. If you don't even know what the labels are available, you can simply, do exposure graph nodes and project distinct node labels, and that will give you all those node labels, and then you know it. And here you know that there is under node property raw data, so you can start doing exactly like I did over here. You expand that, you parse the JSON content of a node property, and then you retrieve the raw data here. Okay, and you also parse that one. If you look under the raw data, look, there are, obviously this is only for this record specific, okay, but the information over here can vary. Over here, the specific node, which is the Woodgrow Woodgrow SRV1, okay, in this specific one, then you have this machine is exposed to the internet, so exposed to the internet is available. So you basically use right here, okay, and that's how you start building those queries. Now, let's say that you want to extract the assigned role for resources. You don't know exactly what are those roles, okay, in terms of permissions. You can do that as well. Okay, so I don't want to go specifically on a a specific resource. I just want to say, give me pretty much those resources that has an attribute called has permission to, which tells me that that resource can, as a role or has permission that can do something like either read, write, do something more dangerous, okay, to another resources. So I can run this query, which is a little bit longer. And here you can see that now I have a pretty big results here, really big, obviously, because I have not specified or filtered to specific resources. So right here, I have a bunch of user accounts, okay, and that have specific role assigned. If you look here, okay, that you can identify by looking a little further in the assigned role, and then um, the actual resource, the user account, that has specific role and permissions on various type of resource type. Okay, so perhaps has this account U6703 has delegated permissions or some specific permission that you can read from here to do something within the Microsoft resource deployment. Can also do something on the logic apps, so workflow, has permission to manage network security group, network interface. And you can see the actual resource name of where he has this kind of permissions. Perhaps here the workflow is called the NR rule, or the interface is whatever server name win11 u-nec. So as you can see here, now you're starting getting very good, valuable information like, oh, I see some user accounts that can do many things. If you scroll, there are tons of resources over here, but if we scroll through, you're going to see also virtual machines or other resources. They probably have a configured, obviously it's a lab, that were configured specifically to have a permissions or role assigned to other critical resource. But this is not just right now for this query. I just want to show this query that allows you to actually do some analysis. Like, all right, well, let's see if any resources in my environment that specific permissions or whatever permission to have, and tell me what those roles and permissions are applicable to it. So give me the target resource and the type and the resource name, okay? Now, as we move it down to the samples and then other samples, the queries are become a little bit more complex. Still, it's not complex, okay, but a little bit more. So here, supposedly that I have identified a resource that has permissions, okay, and I want to look a little bit more into detail just for that resource. So how do you build now that query for the specific resource? Well, you can use a resource name, yes, but experience told me that sometimes those names and stuff are not 100% unique, and then the best thing that you can do, actually use the record ID. The record ID in this case is the edge, okay? So again, the edge very much establish the relationship. So what do you want to do? You want to know the edge record, okay? They identify some specific conditions here, and you want to use that edge identity into your query. So right here, I select one of the edge entity. I believe it's not this one. I think someone in here should be, but I can copy and paste the others. And then I'm going to take that edge and I'm going to now use a little bit more advanced type of query by leveraging the join. So I'm going to build a relationship in my query between the edge and the nodes. So as you can see here, I'm starting from the edge by targeting a specific edge ID, and then I'm also querying the the node database, and then I'm looking for the relationship which between the node ID of the two, the node ID of the graph, and then the ones the two tables basically. Okay, so if I run this query, again, it's a little longer query, and run it. Let's see if it finds anything. I don't remember if this. Yeah, it did. Okay, so what's happening here? We find that this user account, the user account 6U6246, which is a user, okay, has permissions, okay, as a reader, as you can see, okay, on a target node. So it has permission on this target node, which is sub sentinel. What is a sub sentinel? It is a virtual machine, okay. So already here now, you start getting a little bit more detail, but specifically for your defined analysis. You started with, okay, a little bit more broader, but now I'm going to nail and zero in to what I'm actually hunting for, okay? And this is still proactive. All this is all proactive right now. Some other best practice that I mentioned earlier was make it a mix set and bag keys, right? So here is one of the best practices to learn a little bit more about the context of the, the actual table, okay? In this case, I'm using the graph node. And then if I run it, what I'm doing here, I want to learn, okay, what's inside the node property of a node called node referring into a storage account. What goes in there so that I can leverage those properties for further enhanced query or advanced, a more complex query. So here, first thing I do is run the parse JSON and I'm gonna make a set, but the set is coming from a collection of the key extraction. So I take the keys, extract and I put in a bag, and that's done with the bag underscore key. And then I make a set. So I make another set, which is basically, it's sort of like an array, okay? You have the data pretty visible, that's good. But you know what? I want to look a little bit better. So what I do, I'm gonna expand those keys, and then I use the MV expand, which is very important to learn MV expand because it allows you to manipulate all those records, especially when they are in arrays. If I do that, I'm gonna get the same exactly data, but I have it now in a form of a record. So I can see a little bit, in a record. I can also modify and project this thing, so many things here. Now, what about if I want to identify something that has permission to sources like a users, all right? So I'm going to say like, I want to see all the relationship in the edges where our label has permission to, and then the node label is a user. So all the user that has some sort of like permissions. I can easily do that. And then that way, I see all the users that have some kind of permissions, okay? And the actual target node where those permissions are applied, okay? And then I say, what about if I want to I want to provide all the path from specific node ID to a node with a specific label. This is a little bit more complicated because I'm gonna use a graph match, okay? First of all, actually, I'm gonna use a make graph, which is gonna create that graph, and then I'm gonna do the graph match in order to expose the data. Let's see if it's anything in there. And here we go. We got additional data informations here. Now, those are a little bit of some samples just to show you how to navigate, how to build simple or a little bit more advanced query, and to learn about the content so that you can master day by day the query scripting here for those two tables. Let's move on a little bit into a little bit more complicated type of query. Here, it's a long query. What I'm doing here, I'm basically performing multi-hop traversal to uncover risk path, okay? On this other one, I put a compromised account, and then I'm calculating the risk of those accounts. Then I have one more, which is just like a regular proactive multi-hop traversal type of query. Let's run this thing first, okay? So if I run this, it should. Yeah, come on, come on, come on. It's a little bit more complicated query, so sometimes they can break it, can time out. So here I have actually the results. So look here. So this is very proactive. What I'm trying to do over here is I'm trying to kind of like emulate a little bit of attack path analysis. So basically, I'm looking to these machines and says that from this initial Win 10 E9 12, if this machine is compromised, okay, then I can also compromise this other machine, the Win 10E, which can then compromise Joanne Lawrence, which is basically an account, and then compromise Jad Copilot is user trial, which is probably some kind of like AI service here. Of course, I can make this query a little bit more user-friendly when it explains a little bit more the context here. For this demo, I just didn't want to make a complicated, too much long query. But as you can see, the powerful behind those two tables allow me to proactively build my own attack path analysis sort of thing, all right? That's very important, okay? Because also attack path are vital for your security postures to sort of know exactly what you need to remediate to choke the possible attack vectors. Now let's go into this, okay? Actually, no, to this one. All right. Oh, which one is it? Sorry. Okay, this one. This is one a little bit more, actually, those two are very much similar. Because we don't have much time, I'm just gonna show this one, and then we're gonna go over questions. So this is a little bit more reactive, okay? So let's assume that I have a bunch of alerts. It's just for this demo, obviously, right? Related to identities, to user accounts, okay? Those are actually obviously simple alerts. They're in the lab, but then we have a bunch of alerts of attempt to breach user accounts. We have a password spray, anomalous token, unfamiliar sign-in problem. I mean, a bunch of type of alerts. They identify some sort of like attempt to compromise or to breach a user account. There are a bunch of user accounts over here, okay? Tons of it. Now, let's say that I am the SOC analyst that is at the stage 1, so tier 1, trying to triaging these alerts. Okay, so I'll come across here, unfamiliar sign-in properties. And I'm looking to it. I'm gonna read about it. I'm gonna learn about it. And it says, okay, this is important. Obviously, it doesn't look like has been successful. There is a sign-in which is unfamiliar, but it's not yet. It's either not yet successfully breached, or it's just the beginning. So I want to know exactly what damage can be I have to face in case of a real breach, or if this is breached. Okay, so because it's a user account, I want to know exactly what this user account can do. Now, obviously, there are tons of other ways to learn it. But what about if you very easily, very quickly have a script or a query like this? And it says, okay, I'd like to compromise account to be 1075. I want to know exactly what can it do in terms of with its own permissions and the total risk associated. Okay, in that way, I can identify and trying to understand what level of escalation I have to put through the ticket. So, of course, I already ran the query early. I can run right now. It's going to take like probably few seconds. By the end of the day, if you look at it, it finds that these user accounts U1075 can access a key vault and has a role of a contributor, and it can access a key vault. This is very bad because obviously be a contributor, I can do a lot of damage with. Once I can access that key vault. If the key vault holds secrets, keys, and pretty much have a lot of the secret keys, which gives access to a lot of other areas, right? And total risk here is 150. It's pretty high. The highest is 200. Then the other thing that I see that same user on a key vault, okay, exactly the same key vault, he also has a logic app contributor, which basically tells me that it can have a logic app that can also, okay, be manipulated if this kind towards the key vault, if this account has been breached. So this is very much reactive, right? So this is another way to show the powerful value of those two tables, like not only proactively find the information, but also reactively trying to learn more about some compromised resource. Here, the same concept, if I run this one on the other end, it won't run because it's a little bit more complicated and exceeds the memory. By the end of the day, it will give you an attack path starting from this user account. Okay, basically the typical attack path chain where it says, okay, if this user account is breached, then the user account can do 1, 2, 3, 4, so on. So it gives you the chain of the vector, the vector chain, okay? But it doesn't run because it's a little bit more complicated right now. I have to optimize a little bit. Now, before I finished and we go to questions and answers, I also want to highlight one thing. I show all those examples through the actual Advanced Hunting portal where you can run the query right from it. You can save it, you can do whatever you want over here. But what about if you don't have access to here? You don't have access to this portal. Well, you have an options. And the options is basically, let me hold on a second. Let me bring this to it. You can actually use either like a Jupyter notebook with a Python to do pretty much the same thing. Okay, have a simple query, which we already had in our early example, and then here are the results. Okay, you can actually build a Jupyter notebook that allows you to query the alerts and take all the user accounts and loop through them, and each one check into those two tables some specific information like what permission this user has, what are the attack vectors that the user is prone to. I mean, the powerful here is enormous because you not only you have now the query language that allows you to grab the data and modify as you wish, but then you have the power of the Python, okay, to manipulate everything as you wish. End to end, that is endless over here. Obviously, you can also do things like create your own script, your own Python script, and you can run it, and you have exactly the same thing. I mean, you have a multiple option. Now the question is, how do I do that? Well, the answer to that is we have an API that allows you to do the query via code, obviously. And the API is through the endpoint graph.microsoft.com, and you have to query basically the hunting query. It's called I forgot it's called the hunting something. Let me see, I have over here somewhere. Yeah, it's basically called the run hunting query That's basically the full API. But in here there is a client. There is actually an SDK for Python that it is built for this. Actually, there is a graph service client, which is basically, I'm sorry, there is an MS Graph, which is an SDK module for the Python to do this. Now, all the informations about the actual SDK and how you install it, where you get it from, all the information about the endpoint, everything is included inside of my deck at the end. So you got all these informations here, okay, in order for you to replicate some of what we did so far. And now I want to thank you for all your time, and then I'm open for questions.
Thanks, Giulio. Great, so we have a couple questions in the chat, and then if attendees have any more questions, please feel free to keep submitting them. Our first question says, if they are getting brute force and password and MFA are not successful, is there something we should be doing for that?
Oh yeah, if they get something like MFA alert, something like that. I'm sorry, can you repeat the question? If they get MFA what?
Yes, if they are getting brute force and password and MFA are not successful, is there something we should be doing for that?
Absolutely, yes. So basically, at the end of the day, those are going to be generated in formal alerts, right? And all that data is contextualized within, it's basically stored within those two tables. And then they can be obviously leveraged in the same way that I show, very much same way that I show that user account that was sort of ish breached, and then I try to understand a little bit more. So that's where they can look at. Obviously, this is a very techy way to do it. The platform itself, the entire exposure management, entire XDR, entire Microsoft Defender portal allows also very easy visual portals that they can use to, obviously triaging the event, the alert, and learn a little bit more. Okay, this is a little bit more like when you try to do hunting. Next question.
Perfect. Yes, the next question says, if I am using both DFC and SEC exposure management, do I need to do something for integration, or is it already set up behind the scenes?
I'm sorry, the DSC?
DFC. Defender for Cloud, I'm assuming.
Oh, Defender for Cloud, yes, and Defender for Cloud, yes. They're already integrated. There's nothing you have to do. They're automatically integrated.
Perfect. Great, and then it looks like the last question says, how does has permissions work with users that have roles they need to PAM into? When we run the query, will it show what they have at that time or what they can escalate into?
That's a tough question. I never explored that use case. What are they referring to PMIs? Basically, is the permission management elevation. So it's like me as a user account, I have maybe the least privileged type of a role and access, right? So I may have only the read, and then but I want to do X, Y, Z. I have to elevate, and then I'm going to like in the PMI to do the elevation stuff. So that I don't have a question. I'm gonna take that question and maybe answer back to this channel, I guess, because I'm not sure exactly if once you do the elevation, that is, how do you say, it should be basically traced into the database, but I'm not sure 100%, so I cannot ascertain and say yes or no right now.
Okay, sounds good. The next question says, what is the relationship between the tables you introduced and other Microsoft services?
I'm not sure exactly the question. I mean, the relationship between those tables, other resource, so those tables will, those tables are specific for exposure management, which will basically collect and correlate tons of informations. They are coming from multiple feeds. Telemetry data that is generated by cloud the cloud security product like Defender for Cloud, or we have a connector for third parties, a solution like vulnerability management like Qualys and so on and so forth, or any other product as well. But within the Microsoft stack, Defender for Cloud is included in that. MDI, MDO, which is basically Defender for Identity or for Office, and including the same thing for the Microsoft Defender for Endpoint or for the cloud apps. All those are already integrated. So basically, relationship, it is already built within. Now, other relationship are going to be, how do you say, added in form of connectors. Right now, today, we have a few connectors, but it is actually a form through the portal to ask and request additional connector if they're valuable. So that's pretty much it.
Perfect. And then the last question before we drop here says, how do I confirm account enumeration performed on your Active Directory using NTLM is legit or not?
It is legit, but so you must have what do you call Microsoft Defender for Identity, which is extends to the Active Directory. Okay, and that information is then obviously telemetrized and then included here. So then it's just a matter of learn a little bit about once the data is in, learn about how the data is exposed to the JSON on the property itself. Okay, so I don't know top of my head what to look at it, because again, there are so many types of different data in there, depending on what is collecting from. In this case, if you have an Active Directory and the Defender for Identity, you should be able to see this data. It's just a matter of studying a little bit the JSON in order to nail in the filter. Okay.
Perfect. Great, sounds good. Well, thank you so much, Giulio, for being our guest and for sharing the great information with our community. Also, thank you to the Q&A team who helped us with answering questions and providing the resourceful information. To all the listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Together, we can make a global impact. So join us at aka.ms/securitycommunity. This is also where you'll be notified about the upcoming webinars, events, and other announcements. For those of you who may have additional questions on the topic we just covered or other product-related questions, please feel free to raise them on our Microsoft Tech Community discussion space at aka.ms/MDC-community. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.